Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, subscribers, viewers, and future engineers. There is another problem, a Vitamath problem. I hope that this problem will help you improve your way of thinking in preparation to your engineering life. And to those who want to anticipate the solution, you may do so by pausing the video. And I hope that you will improve in the way you analyze problems in mathematics. That's a way of disciplining yourselves in order for you to be or to excel in engineering. So here we go. Find the area of the shaded right triangle inscribed in a quarter circle shown if the left vertex touches the midpoint of the radius. The radius is 20 centimeters long. So this is the original figure. Sorry for the blots, the solution. I do this so that the file size will be lesser and so that it will end in a short number of minutes only. So take note that at this point on the periphery of the quarter circle, the angle is 90 degrees, and by principle, chords drawn to the ends of the diameter of a circle are perpendicular to each other. So that means one idea is if we draw the other half, left half of the circle, it becomes semicircle if extended because the angle here is 90 degrees. This extension of the right leg will pass through the other endpoint of the diameter as shown. So, because the radius is 20 centimeters long and this is the midpoint, then this is r over 2, which is 10 cm long because the radius is 20 centimeters long. Therefore, the shaded area, this green region of this right triangle is equal to the area of this big right triangle, which is 1/2 40 times the height, minus this area of the unshaded part of the triangle, 1/2 of 40, the diameter is 40, times r over 2, which is 10. So the problem is the height. But take note, this is r over 2, this is r, so we can find the slope of this. And if we drop a line from this right corner, right end vertical line, that's the height of supposedly this big triangle here. And the angle, the measure of the angle here is theta, which is the same as this. So the slope is the same. And since we can find the slope of this right triangle, we can also find the slope of this uh, angle. And, and the height can be expressed in terms of this side here, which is also the side of a right triangle. So that's the plan. So this is 20 radius and this is r over 2, so 10 centimeters. And this is also 20, so that's why the diameter is 40. So that's area 1, the unshaded part, and let's call that area S. So that's r over 2 also, then area S. So area S is equal to 1/2 of 40 times h. So I'll call that theta. That's also theta. And we will call this side as y. So 1 half of 40 times h minus 1 half of 40 times 10. So that's area S, 1 half of 40 times h minus 1 half of 40 times 10. So the problem is just h. And from the figure, h is y cosine theta. And let's set up the slope here. Let's have 10, 20, but we can reduce that to 1 vertical, 2 horizontal, then square root of 5 the hypotenuse. So this is the expression for area. So the slope again is 1, 2, then square root of 5. So therefore, h is y times cosine theta, and cosine theta is equal to 2 over square root of 5. So again, h is y cosine theta, and y is from this right triangle, y is opposite to theta, and the hypotenuse is known, which is the diameter, which is 40. So therefore, y is hypotenuse times sine of theta, 40 sine theta. Then h, because y is 40 sine theta, then we just copy cosine theta. So that is h. And from the figure, sine theta is 1 over square root of 5. Cosine theta is 2 over square root of 5. Substituting, then h is 40 sine theta 1 over square root of 5, and cosine theta is 2 over square root of 5. So that's why it is 16. We then substitute the value of h here. So from there, we can now compute the area of the shaded region. So area S is 20 times 16 minus 200. So 320 minus 200, area S therefore is equal to 120 square centimeters. So those who attempted to solve this problem may have their own way of solving it. As long as the answer is the same, 120, then that's fine. At least you have your own way of analyzing the problem. So I hope that you were able to understand the explanations and the solutions. The solution is just basic trigonometry, but the idea is especially the fact that for any circle, from any point on the periphery of the circle to the ends of the diameter, those chords are perpendicular to each other. So that's the important thing to remember about principles on circles.